All right, so 3.5. Let me do this. Rational functions and their graphs. Now, when we think of rational functions, you should think of ratios, and ratios look like what?
Ratios.
What do they look like?
A number, a colon, and a number.
Okay, and it could be a fraction also, right? Because that's what a number, colon, a number means. It becomes a fraction. So we have P of X, and that's just what they call it, over Q of X. So it's a function over a function. So you're going to have an equation on top and an equation in the bottom. When we're looking for the domain, we're going to be using the Q of X, which is your denominator. So when we look for the domain, we have to look for the Q of X. Now, here's the first example. So find the domain. And only problem number 1 from your assignment deals with this. The first problem that we're going to be working with, so f of x equals x squared minus 9 over x minus 3. If it says find the domain, earlier I said domain only deals with what part of your equation?
The bottom part.
The bottom. So I'm going to take the bottom part and put x minus 3. We're going to set it equal to 0. And we have to solve for x. That means I have to add 3. And that right there becomes x equals a what? A positive 3. So when they ask you, what is the domain of this graph? When they ask you what is the domain of this graph, it is going to look like this. It is all real numbers. What does the equal sign with the line through it mean?
X does not
Equal 3. So it's never going to be equal what you get there. So they could give it to you like this. They could give it to you in this format. X is such that, with a little line there, X is not equal to 3. This pen is really messed up. It could look like that, or it could look like this. Negative infinity to 3, union 3 to positive infinity. So it's everywhere except the 3.
It's a parenthesis.
Yes, they're parentheses because it's not equal. Because remember, a bracket is used when it's equal to a number. So those are 3 different ways that it could be written in. So which they all mean the same thing. Questions? Let's look at the next one. Y equals x squared over x squared minus 9. So if I am looking for the domain, what do I have to do? Set the bottom equal to?
0.
0. So I'm going to take x squared minus 9 equal to 0. But when I see x squared minus 9, can I factor that into 2 parentheses?
Yes.
What does it become?
X3 and X minus.
X plus 3 and x minus 3. It is a difference of squares. So you set each one equal to 0. And here I get x is what? Negative 3. And here I get x is a?
3.
Positive 3, right? So these are my 2 places where it cannot, the domain cannot occur. So if I were to write this down as 3 different answers, it's going to be all real numbers, x not equal to a -3, x not equal to a +3. There's one. The other way would be x such that x is not equal to a -3 and x is not equal to 3. And then the other one would be -infinity to who?
-3.
-3. Union. -3 to who?
3.
3. Union. 3 to infinity. So those would be your 3 parts. So all those, once again, mean the same thing.
Did the answer change if we were to do it? If we were to do this, before, not factor it out, make it do the same.
It depends, but you need to factor it out. And this one, not necessarily, but if I end up with an x² minus 5x plus 6, you need to factor. And this one, I understand you can move the 9 over, take the square root of 9, you get a plus minus 3. The answer is still going to be the same. Okay, for problem C, the last one from this section, y equals x². Just kidding. X plus 3 over x² plus 9. So in this one, I take my x² plus 9, set it equal to 0. Can I factor this out? No. So if I were to do it the way I mentioned earlier, subtract 9, x² equals to a -9, and you take the square root, we end up with a what kind of answer?
Positive or negative?
3i, because it's a negative inside of the square root. Since this is not a real number, that is not a real number, then my answer is going to be all real numbers, because you're not keeping it from being anything, or -infinity to +infinity. Remember, the answers you get here are the exceptions, but there's not an exception. So this is why my answer would be all real numbers or -infinity to infinity. So question number 1 comes from this section. Are we good? You suppose? The next section, we're going to talk about vertical asymptotes. Vertical asymptotes. Now, a vertical asymptote is a line that goes up and down or sideways. Up and down. So this one's going to be the line x equals a number. It could be a fraction, it could be a decimal, it could be a whole number, positive or negative. It could even be 0. So x equals a number. And this line is where the graph levels off. So, and as I always tell my students to look at asymptotes like they're electric fences. An electric fence is there. You can't cross it, you can't touch it, because if you do, you get electrocuted. So what an asymptote does, and then I'm just going to do something here, it's a little fence. So when you're graphing, your graph comes really close to it, but it never touches it. Your graph goes close to it, it levels off, but it doesn't touch it. That's what it is. So how do you find that? Well, it deals also with your Q of X. So we look at the Q of X and you set it equal to 0. Exactly what we did up top. But now that's going to be your answer. So for example, number 2, find I'm just going to put VA for vertical isotope. So when we look at the first one, we're using the same example. Y equals x squared minus 9 over x minus 3. So what do we do to find it? Take the who? The denominator, the Q of X. So I take my Q of X, my denominator. I set it equal to 0 and I get X is what? 3. This here is your vertical isotope. That's your answer. It's easy. It's the same thing as the top. If it's an isotope, there's no graph on it. So that's why it's not part of your domain. So same problem, y equals x plus 3 over x squared minus 9. What do? Take your denominator, set it equal to 0, but I know it has to be factored out into a plus 3 and a minus 3. Set each one equal to 0. And I get that x is equal to a negative 3 and x is equal to a positive 3. So how many vertical isotopes do I have? 2. These are your vertical isotopes right there. X equals a negative 3 and x equals a positive 3. Are we good? Part C. Which one was the equation? Y equals x plus 3 over x squared plus 9. So we take your denominator, you set it equal to 0. We can't factor it, so we subtract the 9, we take the square root, and we find out x is plus or minus 3i because of the imaginary number. So is there an actual value right there?
No.
No. So this one has no vertical isotope because of that. So if you end up with an I, it is not a vertical isotope because it's not a number, it's not a fraction, it's an imaginary number. Imaginary numbers aren't real numbers. Are we good? Yes? Okay, so this is going to be good for problems 2 through 4. So example 1 was number 1. Example 2 is for 2 through 4. Okay, so we've talked about vertical asymptotes. Now we're going to be talking about horizontal. Horizontal asymptotes. This is the line or a line. Y equals a number because it's going to be a horizontal line where the graph levels up. So when you have to sketch a graph by hand, let's just say you had an axis. There's going to be a horizontal isotope and a vertical isotope, and then your graph is going to occur between those right there, something like that. So that's what those asymptotes do. It just creates a little fence for them not to cross or go over. Now there's 3 rules, 3 situations when it comes to horizontal isotopes. This is a lot easier than vertical. So if you thought vertical was easy, this is a piece of cake. So there's 3 situations. We have to look at the degree. Do you remember what is your degree?
Yes.
It is your what?
The exponent.
The exponent. Very good. So we have to look at your exponent when you're doing this. So you're going to have a numerator and a denominator, correct? So the three situations are as follows. If the numerator degree is less than the degree of your denominator, then the answer is just going to be y equals 0. Situation number 2. If the degree of your numerator is equal to the degree of your denominator, then your answer is going to be LC over LC. Now, we have been using LC for leading coefficient. So you're going to look at the numbers up in the front, and that's going to be your answer. If your numerator degree, it is greater than the degree of your denominator, then there is no horizontal isotope. So we're going to have one of each, so you see how simple it is. It's not that bad, I promise. So for example number 3, let's find the horizontal isotope. So they're going to give you an equation. Let's say this is the first one they give you. Y equals 4x over 2x squared plus 1. So I look at this, and I look at my degree in my numerator. What is it? 1. The degree of my denominator is 2. So when I look at that, is 1 greater than, equal to, or less than 2? Less than. So then numerator is less than the denominator. And if I go over here, my answer is
0.
y equals to 0. Boom, you're done. If I look at the next example, y equals 4x squared over 2x squared plus 1. The degree of my numerator is 2. The degree of my denominator is
2.
So it's 2 less than, equal to, or greater than 2? It's equal to, right? So they're the same. So numerator equals to 2. If I go over here at the notes, it says it is my leading coefficient over my leading coefficient, which means y is 4 over 2, because those are my leading coefficients, that one over that one. So what is my answer?
2.
Y equals 2. That right there is your answer. And for C, y equals 4x cubed over 2x squared plus 1. Degree of my numerator,
3.
3. Degree of my denominator,
2.
2. 3 is what to 2? Greater than. When it is greater than, we are the third one, which we put, there is no horizontal isotope. So those are the 3 situations. Now this here is good for problems 5 through 7. So number 5 through 7 on your worksheet, that's what we do. Now, what happens when there is no horizontal isotope? So when there is no horizontal isotope, then there is a slant asymptote. And to figure out the slant asymptote, we're going to have to use synthetic division. And haven't we talked about synthetic division before? Yes. So it's a piece of cake. It's nothing hard. So for example number 4, find the slants asymptote. We're going to do 2 simple equations. So y equals x squared minus 4x minus 5 and x minus 3. So y again is this one. A no, because the degree here is 2, the degree here is 1. The numerator is greater, so that's why it's a no. So when you do this, you just use synthetic division. 1, -4, -5. Where do these numbers come from? 1, -4, -5. Now, which is a number I have to put out here?
3.
We set the denominator equal to 0, and we get x is what? 3. So that's why we have to use a 3 here. Are we okay with that? So the rule was we bring this guy down, right?
Yeah.
And this is a
3.
1.
Oh, 1.
Yes.
Oh.
It's a 1. We multiply 3 times 1, which is a
3.
3. -1 plus 3 is
One.
-1. 3 times a -1, -3, and this is a -8. Now, this we know is your remainder. This is your constant, and this is your x. My answer is going to be y equals, and you only care about that part, which is x minus 1. And I'm done. That's your answer.
So you switch it, what your x is, like whatever your x is,
You don't switch it. Where did I switch it? This is a 1x minus 1. I didn't do any switching.
Oh, okay.
I didn't do any switching. So let's try one more, just to be on the safe side. Y equals 2x squared minus 6x plus 7 over x minus 2. So go ahead and set it up. I'll set it up in a little bit. Number outside has to be a 2. 2, -6, and 7. Bring the number down. That's a 2. And that becomes a what?
4.
4. This becomes a -2. That becomes a, and this is a 3. But this is my remainder, constant, and your x. So my answer would be y equals
2x minus 2.
minus 2. Exactly. So you only care about that part, not the remainder. So this here is for number 8. Are we good?
Yes.
In the next section, we're going to look for the x-intercepts. And what we need to do is take your numerator and set it equal to 0. That is going to be the easiest way for you to do this. So you only care about your numerator when it comes to x-intercepts. So for example number 5, and we're going to do 3 simple examples. We're going to find x-intercepts. We're going to do 2 actually. So we're going to let y equals 3x squared over x squared minus 4. So in order to find the x-intercepts, who do I have to take and set it equal to 0?
3x squared.
The 3x squared, set it equal to 0. What do you do to solve for x? But divide by 3. So I get x squared is 0. And then if you had to take the square root of 0, my answer is still what? 0. So my x-intercept, 0, 0. You're done. That's it. Can't do anything when it comes to a problem like that. Now, what happens if I get a problem that looks like this? 2x minus 1 over x minus 1. So who do I need to set equal to 0?
2x minus 1.
2 minus 1. So 2x minus 1, you set it equal to 0. You add 1. 2x equals to 1. And then what do I have to do? Divide by 2. And I find out that x is what? 1/2. So what is my point going to be? 1/2, comma, 0. And one more just to be on the safe side here. If I get y equals x plus 3 and 2x minus 7 over x squared minus 1. How many x-intercepts are you going to have for this problem? 2, because how many factors do you have on top?
2.
2. So I have to take x plus 3, set it equal to 0. But I also have to take 2x minus 7 and set it equal to 0. So it's still, even though there's 2 factors, you still do the same thing. Set your numerator equal to 0. We subtract 3, x is what? Negative 3. So my order pair would be negative 3, comma, 0. For this one, I must add 7, 2x equals to 7, and then we divide by 2. If it's reducible, you would reduce. If not, it stays as a fraction. So my answer would be 7 over 2, comma, 0. So there would be 2 problems, right? I mean, 2 answers. So this is for problem number 9. Problem number 9 from your worksheet. There it is. One more example. So for example 6, we are dealing with the x-intercept. Not x, what did I say? X. We're dealing with the y-intercept. When we deal with the y-intercept, we do let x equal to what? 0. So this one's going to be a piece of cake. You just replace every x with a 0, boom, and that's your answer. So for example number 6, find the y-intercept. I look at A, and I'm using the same example, 3x squared over x squared minus 4. So what do I have to do to find the y-intercept?
Put 0 next to x.
So 3, 0 squared minus 0 squared minus 4. What is 0 squared times 3? 0. What is 0 squared minus 4?
-4.
Negative 4. But 0 divided by negative 4 is still what?
0.
0. So this is your y, so my point's going to be 0, 0. But what happens if we have this problem? 2x minus 1 over x minus 1. So 2 times 0 minus 1 over 0 minus 1. So 2 times 0 minus 1 becomes what? Negative 1. 0 minus 1 becomes what? Negative 1. Negative 1 divided by negative 1?
1.
1. So that's your y. So my answer is 0, 1. Easy? This here is for problem number 10. Now, for problems 11 through what? 11 through 16. For problems 11 through 16, all you have to do is graph them. That's it in your calculator. But it deals with transformations. Do you remember us talking about transformations before?
Yeah.
Moving up, moving left, moving down to the right. So for this problem, it looks something like this. So I don't know if you remember, the number outside determined if the graph moves which way? Up or down. So if it was positive, it moves up. If there was a negative, it moved down, right? with the H. If the H was positive, which way did it go? Left or right?
Left.
Left. Very good. If it was a negative, it moved to the
Right.
right. So this is just a refresher in case you don't have a calculator. So if I were to just give you some weird problem that looked like this, x plus 5 plus 3. Where does this graph move?
Up 3.
Up 3. So I could tell you that up 3 means there is an isotope at 3, like this. And it goes which way? Left 5. So that means at negative 5, there is a little isotope here. So the graph, it's either 1, 2, 3, or 4. It's in one of those sections. But if you graph it, you could see it. So the easiest way is just for you to graph them. And that's it.